Tanis is the last one up, and then we're gonna sail fast. We got that drawing for the data station, some other stuff, and Q&A real quick. All right, this is a 4-line bio you guys are gonna love. Seriously quick. Tanis is an Oregon AMS member and climate science graduate student from Oregon State University. Tanis was also a former OSU AMS student chapter president. Tanis is returning for his 4th consecutive year presenting at this conference. Ladies and gentlemen, Tanis Leach.
Strong-ish El Nino with a negative PDO. What could possibly go wrong this winter? I mean, what's the point of even predicting if everything's up in the air? Well, we'll try anyways. But first, I do have some housekeeping. So, if any of you have not seen my YouTube channel, I actually did correctly predict the February 22nd, 2023 snowstorm in Washington County before the models flipped onto that. So, if you want to see how I predicted that, I have a 38-minute recap video on my YouTube channel. Weather and travel routine is excessive. The second housekeeping thing is, I do have a bit of a disclaimer. This is one of the forecasts and intended to provide a general sense of what may happen. Once it is not a necessary happening, nor is an excuse for you to not be prepared for any cold winds, or ice storms that may or may not happen this winter. Right now that that's out of the way, let's talk a little bit slower and go into our scorecard from last winter. And I love how the graphics got screwed up, but anyways, last winter went pretty well at my October forecast because for my water precipitation on the high end of my margin of error, but ended up working out pretty well. The average temperature departure here in Portland, I predicted below average, but not severely below average, which ended up verifying. The lowest winter temperature predicted under 20 degrees, turned out to be 18 degrees. I suspected a few windstorms would happen, but nothing major, and that's exactly what happened. Most active time, I only predicted that during my December update, so it's not applicable in my October prediction. That the time that I predicted to be most active was the only time it wasn't active. And the April 1st snow depth, I predicted near normal during my October prediction. I changed in December to above normal, and while that was true through the Cascade Basin as a whole, at the Mount Hood Snowtell site, I was off by 1% on my December forecast, so technical bust there. And then for Valley Snowfall, unfortunately, it did get cut off, so for the October forecast here in Portland, I predicted 1 to 5 inches. For our friends down south of Salem, down with Corvallis and Eugene, I predicted 2 to 8 inches. It was a good forecast down there, wasn't so good up here. I changed it to a 2 to 8 inch forecast valley-wide, and I verified that via a population weight, which turned out to be 7.72 inches, so that verified for the December forecast despite the big snowstorm up here. So on to my methodology. So I use what I call an adjusted analog year approach, using ENSO as my primary method with the ONI. I confirm it using the Southern Oscillation Index, and I also use analog years back to 1900 rather than the typical 1950, as the Australian Bureau of Meteorology has actually compiled a list of La Niñas and El Niñas going back before the ONI index even started, using the Southern Oscillation Index. I also use both the Pacific and the Atlantic multi-decadal oscillation, though primarily the Pacific. I do also use the sunspot counts. And then I do not weight the analog years equally. Analogs that are closer condition-wise to this year will have a higher weighting compared to those that are further away condition-wise. I will also make adjustments to analog years using statistical analysis when appropriate. So if there's a statistically likely or unlikely chance of something happening, I define that as 90% or greater for something that typically happens in the Portland area. Analogs will be adjusted unless if there's a clear trend in the analog year showing the opposite. And I will also adjust if there's like general trends based off of previous seasons when appropriate. Other adjustments I do, snow prior to the 1970s have been adjusted to a 4.3-inch average per winter, which have been our average snowfall since the 1970s decade. I also changed the averages so that I adjusted to each decade's average as well, so that counters climate trends that have resulted since 1900. And then also all forecasts will cover what has happened in 1 out of 3 winters in Oregon. So it was just flipping a coin. I have a 1 in 3 chance of getting it right, essentially. So should we be worried for the worst case scenario? No, like football. A lot at stake. 75 inches of snowfall, 3 major Arctic blasts, temperatures below 0, and 9 degrees below average. So here is your examples. Here's December. Doesn't look too bad yet. Just some snow at the end of the month. Okay. On to January. Okay, I think some heaters are going to break in the middle of the month, especially considering there's 29 inches of snow on the ground. And then February. Oh, those 70s sound so nice right now. Disclaimer, that is not the actual forecast. That is the worst case scenario in case anyone asks. So now onto the actual data in oscillation, and I will not go back over the whole spiel of what is, and so I'll just go over the outlooks. Looks again, US outlook, strong El Nino, you've seen them before. The CFS outlook, I don't know what this dip in November is, but even despite that dip, it is showing a weaker end of a strong El Nino, but still a strong El Nino. Looking at other models across the world compiled by the Australian Bureau of Meteorology, they're showing a peak El Nino month in early January. Keep in mind that that is a 1-month average, not the 3-month average that the ONI uses. So the actual December, January, February average would probably be a few tenths of a degree less than that. It does taper off when we go into March, but still looks to be a strong El Nino, more favored by pure ocean temperatures. So the differences between a moderate and a strong El Nino in the Portland metro area, both don't have great odds of snowfall, with about a 50% chance of having no snow in general. Moderate having slightly better chance, with median snowfall actually registering versus a strong El Nino not even registering. Average temperatures through the winter, moderate El Nino, near average but a little bit above average. For a strong El Nino, strong signal towards above normal temperatures. And I also found it interesting, after adjusting for decadal averages, no year has been more below average more than 3/4 of a degree Fahrenheit. So below average year does not appear likely using that alone. Median lowest temperatures for both were in the lower 20s, so not that much warmer than our actual median lowest temperature of 20 degrees. And 3 Arctic blasts split between the 2 ENSO states, all of which occurred in December. And a moderate El Nino has a water year rainfall median of actually about 3 inches below the long-term median, but a strong El Nino changes that to right at the long-term median. Mountain snowfall, generally okay for moderate El Nino, but strong El Nino, it's bad if you're looking at the lower elevations below the ski resorts, but ski resort base elevations and above, you'll still have enough snow to play with. But also, major windstorms in ENSO, so Cliff Mass put this graphic together. He's shown this before, and it's also included in his Pacific Northwest weather book. A major windstorm year typically is unlikely the further you move away from a neutral year, with the highest departure from average with a major windstorm being about 1 degree Celsius. So that would be equating to just barely a moderate El Nino or La Nina. The year that occurred was a moderate La Nina. Southern Oscillation Index the last 5 years, we are the negative phase, signifying that we should be going into an El Nino. However, we're not that deep into the negative phase, so atmospheric-wise, it could act a little bit more moderate, at least that's what I'm thinking from that. Pacific Decadal Oscillation, we are still trending downward, though it has flattened out the last few years, and I have found no strong El Nino that has had a consistent negative Pacific Decadal Oscillation the entire winter. It's either been a positive Pacific Decadal Oscillation, or it's been negative but dipped back up to neutral for a few months. So we'll see what happens this one. And the Atlantic Multi-Decadal Oscillation, been pretty steady the last couple of years, staying in the positive phase. This primarily just affects our precipitation by about 1 inch each way. And when the Atlantic Multi-Decadal Oscillation is positive, it tends to increase our precipitation. sunspot count for about 35% through the current solar cycle, signifying that El Nino conditions are favored as well. So what does all that mean, and which analog years did I pick? Well, let's find out. So I picked 21 different analog years, 5 of which I declared as top analog years. All but one of these analog years are El Nino years, with the exception of 1993 to 94, which I found an interesting case because despite the O&I being neutral, the Southern Oscillation Index was in the negative pretty deeply. So the atmospheric conditions were a little bit more El Nino-like than a neutral year typically would suggest. So the other comparisons here, so 1919 and 20 and 1951 and 52 both had a moderate El Nino, but a negative PDO, while the AMO phase disagreed on these 2 years, and the sunspot progression also favored an El Nino on these years. 1957 to 58 and 65 to 66 were both strong El Ninos that had a neutral PDO, but the atmosphere favored a negative PDO. And they both were in the positive phase for AMO, and the sunspot progression for 1957 to 58 started to favor El Nino at that time, but 1965 to 66 actually favored a La Nina at the time. 1993 to 94, like I mentioned, despite it being neutral, I did negative SOI. It did have a negative PDO and was the first sign that the PDO might be flipping in the long term, which occurred in 1998. The AMO was negative, but there was also signs that that was beginning to flip into the positive phase. The sunspot progression was also favoring El Nino at that point. Some extreme events that occurred 1919 and 1920. December was a pretty active month. December 9th through 10th had 17.5 inches of snow split between those 2 days in Portland. Down south got stumped with nothing. They got snow later in the year, but not as much as Portland. It was followed by 3 days with lows in the single digits, bottoming out at 3 degrees. And also, it was the only time Eugene failed to hit 10 degrees or higher for a daytime high temperature. December 13th, 1919, it was 9 degrees for the high temperature. 1951 and 52 was a little different. It was consistently, but not extremely cold. The departure from average was the same on these 2 years. And there was 9.6 inches of snow, mostly in January. That was pretty consistent valley-wide. 1957 and 58, I could probably skip that if it wasn't for the fact that it was the highest departure from average that was reported at PDX, though not the downtown station. That was back in 1917 and 18. Interestingly, a La Nina year in that case. 1965 to 66, another done in Portland, but not in Eugene. Eugene had 7.7 inches of snow, 2/3 of which was in December. And then 1993 to 94, despite it being the 3rd driest water year on record, there was still a valley-wide snowstorm. In February, water year-wise with the rest of these, they were all near to slightly below average, so that should slightly improve the drought conditions. Also, I didn't mention this earlier, but 1957 and 58 came off of a triple dip La Nina, which we are also coming off of. So looking at the data for each year, these are the departure from averages. The top analog years are in purple. So my all analog median is 0.7 of a degree above average. But after I weight everything, it actually turns out to be about 0.4 of a degree below average for my weighted analogs. Water year precipitation, generally supporting below average, but not by a lot, with my weighted analog supporting about 32.5 inches of precipitation. Lowest wintertime temperature. I do expect a cold snap, but probably not an Arctic blast because the December 1919 skews that downward a lot. So the weighted analog median was, I think, 17 degrees because of the skewing. And then adjusted snowfall, the weighted analog year showed 3.1 inches for the adjusted snowfall, but there's still a lot of conflict in the analog years, as you can say. See, so that's where the statistics come in. So what statistics do I have this year? Well, first up, we have 8 consecutive winters that have had measurable snowfall. This is a record high, and a chance of a ninth occurring unadjusted is 5.3% chance of. not really that good. Only 3 winters have produced a temperature under 20 degrees with less than 1.5 inches of snow. All of these winters had 0 snowfall, so that reduces the odds of an Arctic blast, especially if I'm using this statistic as the tiebreaker here for my final forecast. We've also had 3 consecutive winters in Portland where we've had 6 inches or more measurable snowfall in Portland, the top third of all winters. Chance of a 4th occurring unadjusted is 2.5%. And interestingly, the frequency of 6 inches or more in Portland has not decreased, even if I do not adjust my snowfall in my data set here from the National Weather Service. In addition, there's been 9 winters without a region-wide Arctic blast, as Mark Nelson showed on his presentation. A region-wide Arctic blast I define as the upper air temperatures being 12 degrees Celsius or colder at the 850 millibar level over Salem. Chance of a 10th occurring is 7.3%, but because that chance is higher than the no snow chance, I am not going to be using that statistics because those 2 statistics contradict each other. So now, on to the predictions. Let's start with the basics, the boring water year prediction. Your median water year is favored, predicting anywhere from 31 to 39 inches here in the Portland metro area, or between 87 and 109% average for anywhere else that does not experience the same averages as Portland. Winter, I'm also anticipating a near median starting between 13 inches and upper end of marginal error is 16.5 inches. My best estimate for the water year is 34 inches. Temperature to partial, I'm expecting near normal temperatures within about 1.5 degrees of average. My best estimate is right at the long-term average. Windstorms, I don't expect anything too crazy, but I could see a windstorm or 2. Peak gusts between 45 and 55 miles per hour. And then lowest temperature, I am anticipating above 20 degrees for the lowest temperature, with my best estimate being 22 degrees. Then most likely to be active time is December. Onto the snowfall forecast. Mountain snowed up on April 1st. I'm forecasting anywhere from 75 to 110% of normal above 4,500 feet. But if you're going below the ski area base elevations, it gets a little worse, between 60 to 100%. And then for valley snowfall, doesn't look that good in Portland. Below normal snowfall is favored. I'm anticipating anywhere from 0 to 3 inches with the best estimate of a trace. For the central and southern Willamette Valley, I'm anticipating between 1 inch and 5 inches, with a 3-inch best estimate in Corvallis and Eugene. Chances of a snowstorm are on here, and I think it's a coin flip whether we'll see snow or not, despite my best estimate being a trace. This is the prediction I am the most uncertain about as a second disclaimer because of the conflict in my analysis. But do you want to increase the chances of snowfall, or do you want to change the peak time? I hit that slide, great. So, it's actually, ignore my technical difficulties, apparently. So just ask Mark Nelson to find a way to take a day off or get a year sick, because as February 22nd proved, Mother Nature can be fooled when he takes a vacation day. So with that, now,